Stop grabbing your calculator. What if I told you that you can just look at a big number and instantly know if it's divisible by 2, 3, 4, 5, 6, 8, or 9? I'm gonna show you how to instantly find common factors and simplify any fraction without long division. It's not just a theory, it's a set of ancient mathematical speed hacks. We'll use these tricks right now to find a massive common factor in this huge fraction, saving us 3 steps of work. I have been tutoring maths one-on-one for 2 years. In my home country Latvia, I have already helped thousands of students to improve their calculation speed and accuracy. And now my goal is to finally reveal this knowledge to the rest of the world. For the next couple of minutes, we are going rapid fire, covering all 7 essential rules. Let's dive in. Divisibility by 2 is the easiest. If the last digit is an even number, 0, 2, 4, 6, 8, it's divisible by 2. This is your first check for any fraction. The rule for 5 is also very quick. Does it end with a 0 or a 5? If it's a yes, then it's divisible by 5, easy prime check. For 4, you only have to look at the last 2 digits. If that 2-digit number is divisible by 4, then the whole number is divisible by 4. For example, 3116 is 16 divisible by 4? Yes, it is. Therefore, 3116, the whole number, is divisible by 4. Stepping up for 8. Now you check the last 3 digits. Is 112 divisible by 8? Yes, it is. 15,112 is divisible by 8. It's a bit harder, but still faster than the full division. If you found this video useful so far, then click the subscribe button so you'll get more of these videos. Now for the absolute game changers. For 3, you add up all the digits. If the total sum of all the digits is divisible by 3, then the original number is 2. 2436. 2 plus 4 plus 3 plus 6 is 15. Is 15 divisible by 3? Yes. Then the whole number is also divisible by 3. The rule for 9 is a twin for the rule of 3. Again, I'll add the digits up, and if the sum of all the digits is divisible by 9, we're good. For example, 7497. 7 plus 4 plus 9 plus 7, 27. 27 divided by 9 is 3, so bam, divisible by 9. Finally, the rule for 6. It's a combo. Since 6 is 2 times 3, a number must be divisible both by 2 and 3. Check the even number rule, then check the sum of the digits rule. If both pass, then it's divisible by 6. Why does it matter? Fraction simplification. Let's try 108 divided by 144. You will see that both end in an even digit, so it's divisible by 2. Last 2 digits, 08 and 44, are both divisible by 4, so 4 is a factor. However, neither ends with a 0 or a 5, so no, not divisible by 5. Again, 44 isn't divisible by 8, but 144 is. 08 is not. Now the magic rule for 3 and 9. 1 plus 0 plus 8 is 9, divisible by 3 and 9. And 1 plus 4 plus 4 equals 9, divisible by 3 and 9. We found a huge common factor, which is 9. Now we can divide both by 9 instantly, and we get 1612. We know that's not fully simplified, but we are a lot closer. Let's see how fast these rules make factoring large numbers. Countless of times I have seen that it's not like the students don't understand, for example, polynomials, but it's the basic arithmetic of putting 2 numbers together that slows them down and makes it feel like walking in the mud. Like Carl Friedrich Gauss once said, mathematics is the queen of science and arithmetic is the queen of mathematics.